Okay, 1.3 is called functions. Functions are going to be really important for the rest of the semester, quite honestly. Pretty much every section that we cover is going to include something about functions. Consider the relation was born on. We got a set of points listed here. And pictorially, there's a set of names and a set of the set of birthdays. Matt's birthday is April 15th. Andy's is May 3rd. Michelle's is March 26th, and Nate's is May 3rd. Okay. Yes, this is a function because the rule is satisfied. Let x and y be non-empty sets. Then a function from x into y is a relation that associates with each element of x exactly one element of y. So the fact that two x values go to one y value, that's okay. That makes this a function. We don't want an x value going to two different y values. That will not be a function. So here's another example. I've got a set of points, 9, negative 2, negative 3, 5, and 9, positive 2. This is not a function since when you look at the illustration of these, 9 is going to two different places, 9 is going to 2, and negative 2. You can't have that with a function. So two ordered pairs have the same x value but different y values. Okay, so function notation, usually it's denoted by letters like f, g, and h, and others. F of x refers to the value of f at the number x. The domain of a function is the set of all input values. The range of a function is the set of all output values. Those are terms that we've already looked at. For example, suppose that we have a set of points, and f of negative 1 is 5, f of 0 is negative 3, f of 1 is negative 1, f of 2 is 5. Write f as in ordered pairs and give the domain and range. Okay, so f is a set, and in the set is the ordered pairs negative 1, 5, 0, negative 3, 1, negative 1, and 2, negative 5. The domain, we're talking about the set of all input values. The domain is the set, and the range is a set. Okay, so it's important to make sure that you use set bracket notation whenever you write down the domain in the range of a function. The set of all input values. The input values here would be the numbers that are to on the left side, negative 1, 0, 1, and 2. The range is the set of all output values, so the numbers that are on the right side of the equation, 5, negative 3, negative 1, and 5. Okay, now 5 is listed twice, and there'd be no harm with writing that number twice. And in fact, I can write any number as many times as I want. I would only count that as one that is different from the others. So, if I were to write down the set containing 5, negative 3, 1, and 5, that would be fine. What I have written here is fine too. Okay, so we have a function, and suppose that we want to know the following. Part A, we want to know f of 3. Part B, f of x plus f of 3. Part C, f of negative x. Part D, negative f of x. Part E, f of x plus 3. Part F, f of x plus h. And part G, the domain of f. Okay, so f of 3 means that I'd want to replace x with 3. And everywhere I see an x, so I've done that. And 3 squared is 9, times 3 is 27, minus 12 is 15, minus 2 is 13. So f of 3, that's equal to 13. Okay, well, that means that, that 13 would be in the range, and 3 would be in the domain. F of x plus f of 3. Okay, what does that mean? Well, f of x is given to us. That's 3x squared minus 4x minus 2. F of 3 is 13. We just said that in part A. So when I combine negative 2 and 13, I get 11. And so I get 3x squared minus 4x plus 11 is the answer. F of negative x means wherever I see an x in f, and there's a couple of them, I need to replace x with negative x. So I've done that. Replaced x with a negative x. Now make sure that you include parentheses around the x's, the negative x's, because negative x squared is the same as x squared, and negative x is the same as 4 times negative x. Negative times negative is positive. Negative times negative is positive. So I've got 3x squared plus 4x minus 2, that's as far as I can go. Negative f of x means I want negative the whole thing. Negative the function, 3x squared minus 4x minus 2. I've got parentheses around that, and the negative in front, and so therefore I'm going to distribute the negative into what would be the 3 terms there. Negative 3x squared plus 4x plus 2. Now notice how my answers for part D and part C are not the same. Sometimes they would be, but here they're not. And when they are, the function that I'm working with is called an odd function. We'll talk about what we mean by even functions and odd functions in another chapter. But here, I guess, note that I get 2 different expressions as my answer. F of x plus 3 means that I've got to replace x with x plus 3. So I've done that. 3 times x plus 3 squared minus 4 times x plus 3 minus 2. Okay, that would be equal to 3x squared minus 8x plus 27, when I FOIL that out, minus 4x minus 12 minus 2 equals 3x squared plus 4x plus 13. And here's f of x plus h. That's the same as 3 times x plus h squared minus 4 times x plus h minus 2. Well, I get, when I FOIL this out to begin calculating, I get 3x squared plus 6xh plus 3h squared, and then minus 4x minus 4h minus 2. Nothing is in common, and so at that point I'm done with the calculation. There's nothing to combine together. Part G, the domain of f. F is saying whatever the function is, I'm going to square the function. I'm going to take 3 times the function. I'm going to subtract 4 times the function, and then subtract 2. Well, I can do that to any number, x. So x would be all real numbers. Okay. Now, as far as set notation and interval notation, these are 2 very, very common forms of giving answers, and whenever we have a set or an interval as our answer. Okay. So set notation. Suppose I have the set of all x such that x is less than 3. Well, so I'm describing all the x values that are less than 3. As an interval, I'd be describing anywhere that is negative infinity to 3 in that order. and I'd want parentheses at both ends. You'll notice I've got brackets right here. Well, in general, I want to include brackets whenever I'm including the number, which is basically indicated by a greater than or equal to or less than or equal to sign. Anything less than 3 would mean that I'm not including 3. Anything less than that means I'd shade to the left. So here'd be my answer as a set. As a set, I'd say I'd have the set of all x such that x is greater than or equal to negative 7, and my interval for that set would be the interval negative 7 to infinity. And by the way, the order matters for interval notation. Like I wouldn't write 3 comma negative infinity. I wouldn't want to write infinity comma negative 7. That doesn't make any sense. I always want the smaller number first and the bigger number second. Now I'm including negative 7. Okay, since I'm including x equals negative 7. So I'd want a bracket by negative 7, and parentheses is always going to be up by infinity or negative infinity. Those are not numbers, so they will never have in brackets at all by them. On the number line, here I'm at negative 7. I'm including negative 7, so I'd want to have a closed circle there, and include that number. And anything to the right of that number is also included. Okay. The next one, the set of all x is that x is between negative 1 and 3. So negative 1 to 3 would be my answer as an interval. I'd want a bracket by 3 and a parentheses by negative 1. Since I'm including 3, I'd want a bracket by 3. And on the number line, I'd include 3 in that set. So I'd have a closed circle there at that point. I'm not including negative 1, so I'd want an open circle at that point. And anything between those two numbers should be represented. Okay. Next one is the set of all x such that x is less than negative 5 or x is greater than 3/4. Well, x less than negative 5 as an interval means that I'd write negative infinity to negative 5, or x greater than 3/4 as an interval means I'd write 3/4 to infinity. Your book may use the union sign. Here's a picture of the union sign, and it means the same thing. It's as the word or. I just write the word or. Or is only 2 letters. Graphically, we have these two values, negative 5 and 3/4, and we're not including either one of those, since we're not including since we have a strictly greater than and a strictly less than. The first interval is anything strictly less than negative 5 or anything strictly greater than 3/4. Okay. Now, in general, you will always have 2 different sets that will not overlap. Okay, which is always going to be represented by an or situation. An and situation is like the one up here. You have 2 sets that do overlap. Okay, anything greater than 1, anything less than 3, well, there's an overlap there. Anything greater than 1 and less than or equal to negative 3. In the next example, I have the set of all x such that x is not equal to negative 2. So anything that is negative infinity to negative 2 or negative 2 to infinity would work. The only thing is that I want to make sure that I'm not including negative 2, we're basically got a sharp or a bracket by negative 2, and so I'm not including that number. Here's my set on the number line. Here's negative 2 with an open circle there. And anything that's all real numbers would be anything from negative infinity to infinity. Negative infinity to infinity would be how I'd write that as an interval, and on the number line I'd shade the entire number line. So, okay.